such nature. So Jeremy, thank you, and he's going to talk about the basics of electric fencing concepts.
Thank you. So we'll have plenty of time for questions in the field if we start running up on close to the next presentation. This is just as much for you all to ask questions and learn and have dialogue as it is for me to stand up here and ramble, because I can do some rambling. If you don't believe it, ask Dr. Teutsch. So what if I told you that everything you're going to learn here today is the exact same concept, the exact same principles that we've been teaching zoos about for the past 2 decades on how to control their animals? Same things that you're going to learn today, you can take home and apply to livestock, and it's no different than trying to control animals that are much, much harder to control. The first thing we have to remember with power fence or electric fence, it's a psychological barrier. Peyton gave you a great overview of some physical barriers: board fence, woven wire, fixed knot, hinge joint, barbed wire, non-electrified high tensile. Those are all physical barriers, something that's physically keeping the animal from pressuring the fence. With high tensile electric or electric fence in general, we apply a few different concepts and make it a psychological barrier. And with that psychological barrier, we can easily control these critters. As a matter of fact, an elephant's probably the easiest thing to control because they walk around on big ground rods and they touch everything with the end of their trunk, which is extremely sensitive. But any zoo that you can drive to, within a day of Russell Springs, you are going to find the same concepts and a lot of the same products that you're going to see today, or you're going to see in grazing school, or you're going to see in the electric fence troubleshooting school. You're going to see the same thing in those zoos, if you know what to look for. Most of the time, in whether it's the grizzly bear, elk, and wolf exhibit at Memphis Zoo, the gorilla exhibit in the Louisville Zoo, the safari track on Disney's Animal Kingdom, the primary barrier for those animals is going to be electric fence. That is the first thing that stops those animals before they get to you, which the next level is going to be a moat or some type of a chain link or wrought iron fence or big cables. That's the physical barrier, but the psychological barrier is going to be the electric fence. Now, those designs, we've designed those as weeds, grass, vines. You're not just going to see electric fence and yellow insulators. So it's disguised, but if we can use those same concepts we're going to talk about today to control these animals, then there's no reason whatsoever at all that we can't use electric fence to successfully control livestock. And I can go into a whole other rant about electric fencing and temporary fencing for managed grazing, and one of the quickest ways to show profit and returns on your investment is to start some type of managed grazing with electric fence, even if it's one strand of polywire. But it doesn't have to be that hard. Now, I guarantee you that the Knoxville Zoo is not going to use cut-up inner tubes for insulators. They're not going to use water hose cut up in little sections to wrap around the post. They're not going to use rusty wire for their lead out. They're not going to use leftover Romex cable that's made out of copper to run from the Energizer to the fence. They're not going to do those things because they want their fence to work, and they want it to work 24 hours a day, 365 days a year, because your fence system, whether it's electric or permanent, it's the hardest working thing on your property. It has to work all the time. Even when you're asleep or at work, your fence is still working. So we're going to talk about a few shortcuts not to take, but if we apply these concepts, we can easily control livestock with the proper amount of voltage and a proper built system. Any system has multiple parts to it. And if I say something that you see at home that your neighbor does that's not right, don't go home and make fun of them. Maybe try to help them a little bit. Help them improve their shortcuts, because I know nobody here would ever do anything like the water hoses or old rusty wire, right? So don't. And my neighbor's I used to talk about my neighbor a lot until my neighbor showed up at a fence school about 5 or 6 years ago, and I had to change my tune a little bit. But we know our neighbors do things that aren't necessarily right, so hopefully you can take some concepts you learned at the fence school and go home and help your neighbor, because everybody's here that has a fence, it's built right to spec, right? So it is a system, and any system has multiple parts, and if we take shortcuts or slack on any part of the system, what happens to the system? The whole system fails, because everything has to work together. So with power fencing or electric fencing, you've got some very simple parts to it. You've got the fence system itself, the wire, the insulators, the posts, the underground cable, the cutout switches. You have the energizer, the hot box, the fencer, some way to put power on the fence, and it could be multiple different options on the power supply. And then you have the ground system, which is a system within a system. Could it get more complicated than that? Actually, it's pretty simple. So you've got a ground system. The ground system, I need to move this up to number 1 because the ground system is the most overlooked part of the system of almost every electric fence there is, the ground system. And it's also one of the cheapest parts of the system to improve on. I like cheap. I'm a livestock producer, and cheap, I try to insert cheap in my operation anywhere I can. Cheap and effective. Not shortcuts, but cheap. We could say cost effective. The ground system is very easy to improve on, and we'll talk about that later. There's a good publication in your handouts specifically related to grounding. And there's recommendations. You don't have, anytime you see a recommendation, you don't have to go with the minimum. You can always jump up above a recommendation. Whether it's on grounding or fencing or energizers or buildings, anything, you can always go above the minimum, and we want to do that in some cases. And then hidden sometimes is the lead out. And the lead out, you could do all these things right. You could do all these things, take extra cautions, extra care, and then if you miss this one, the lead out, which could be a piece of wire that long that goes from the energizer to your energized fence, if you use a rusty piece of wire or something that's going to corrode or something not big enough, then all your energy can get slowed down in that little section, or a section that's 50 foot long that goes from the tool shed to the fence. So we can't forget the lead out. So energizer-wise, what size and how do I compare? This is not a fun topic. It's much more fun now that I'm not on the corporate side of things to talk about. But what size and how do you compare, and what do you look at? How do you select the right energizer, and what are you actually buying when you buy an energizer at retail off of a shelf? So you've got all these ratings. You've got mileage, acreage, stored joules, output joules, super shock them, burn their hooves off hot. It'll just say that on the package. And then you've got New Zealand ratings versus U.S. ratings, because there's a lot of companies that will build things in New Zealand, which is where electric fence was really pioneered at. They'll build in New Zealand, and they'll export to markets all over the country, including the U.S. For some reason, when that product gets on a barge or a container and comes across the ocean, then all of a sudden it can do more when it gets here. Don't know why. It may have something to do with folks in New Zealand are more realistic about the ratings, and it comes to the U.S. and everybody wants to try to be the biggest and best and do the most hundred thousands of miles. So we'll talk about that too. So let's think about mileage. Almost every package you can pick up is going to have a mileage rating on it. It'll say X number of miles of fence. So let's think about it in a literal sense. So a 4-mile energizer, which is a fairly small energizer, should do 640 acres, right? Kenny, you got any sections of ground in Arkansas? Are you in section country? Well, you can go north and find some, or go west. So once we get a little bit east of the or west of the Mississippi, if you've ever flown over and looked down, everything's laid out in big grids, big squares. Looks a lot different than central Kentucky and most all of Kentucky. Well, one of those squares that you're looking down on is 640 acres, a section of ground. 1 square mile. So if this were to be a square, it's not, but let's just pretend. We'll just make this up as we go. That's what I like to do, just make it up as I go. So if this were a square, 1 square mile. So if I start my pickup truck up here in this corner and start driving 1 mile, 2 miles, 4 miles around the 640 acres. Does everybody follow me? That's the perimeter of this 640 square acre in Kansas. So I should be able to take the energizer rated for 4 miles and go out to Kansas and put it on 640 acres of 1 strand or 10 strand high tensile and effectively control my sheep or llamas or cattle. Right? What the package says. That $79 fence charger on the shelf, it'd do 5 miles. Boy, it's a hot one. 5 miles, 640 acres. Is that realistic? Use your own judgment. So let's take it a step further. You can get the 100-mile fence charger. Woo! Just burn the hair right off of them. 100-miler. Cost some of the cheaper brands maybe $350. That's a lot of money for a fence charger. Do 100 miles though. Let's take that out to Arizona, where they just look at a section and just kind of kick the dust around. No, we don't farm in 600. We farm in thousands of acres. So let's go to Arizona and find us a 400,000-acre square ranch and start driving around it. And you drive around 400,000 acres that are square, and you'll go 25 miles to this corner, 20, and you get back to the beginning, it's 100 miles. So I should be able to take that $300 or $400 fence charger out to Arizona, put it around 400,000 acres or 100 miles, and it control my goats. That's what the packaging says. So let's put that to the side for a minute. What we do know is use these mileage ratings within brands. If one brand has a 25-mile fence charger and they have a 100-mile, then you can accurately assume that the 100-mile fence charger will do 4 times as much fence as a 25-mile. Will the 25-mile do 25,000 acres? Probably not, but we know that it's going to be 4 times more powerful. Don't compare across brands. There is no national or global industry standard on mileage and how they're figured. So what we can bank on is a figure called joules. Joules are like horsepower. Joule is 1 watt for 1 second, which means nothing to me when my cattle go out and touch the fence. But a joule is just like horsepower. It's measurable. The more joules you have on your Energizer, the more you pay for it. The bigger the tractor, the more horsepower, the more you pay for it. When you spend more money on a fence charger, you're spending more money on the joules. Now, you can get extra accessories on a tractor, cab, loader, fancy shifters. That's going to add a little bit to it, but at the end of the day, you start out by buying horsepower. Same way with Energizers. You're buying joules. You're buying that capacity to push power down the fence and shock things. So now that we have a figure called joules, and most all companies will give you a joule rating on the package, then surely we can say, okay, how many joules per mile? By George, we got it figured out now. We can accurately say a 1 joule Energizer can do X number of miles of fence. Makes sense, right? There's got to be some kind of magic formula. So let's look at let's look at how maybe some of the companies can figure things. So couple of New Zealand companies, they're going to say about 0.2 joules per mile, but you bring it across, remember, you bring stuff across the ocean, it automatically just gets bigger and crazier. So you bring it across the ocean, well, it'll do even more. You only need a 0.1 joule per mile. Some cases it's even less when you convert it from hectares to acres to miles to kilometers. So that doesn't make a lot of sense. Well, another brand, about the same thing. So let's say, all right, let's just ease back on what some marketing says on the packaging, because these companies will have this little corner office, and in that corner office is full of people, and they've got colored pencils and blank paper and computer design programs, and they're called the marketing department. And guess what the marketing department's task is? No, to sell things, to sell you things. So and sometimes the marketing departments maybe don't talk to the technical departments, and so let's not listen to the companies 100%, and let's go to Extension or NRCS. Entities that probably have done some research and had a lot of experience. So, okay, let's go to NRCS in Tennessee. Had a lot of electric fence specs over the years. They cost share a ton, one of the biggest pooling areas in the East. They say about 1 joule per mile. Wow, that's a lot different than what the brands are going to tell us, a joule per mile. Let's go to Missouri Extension. One of the first people to write the book on electric fencing for serious grazers. Missouri Extension was heavily involved in that. They say, yeah, Tennessee, we agree with them. Everything's the same. But what about California? Well, they can't. So the extension services can't even agree with each other. NRCS can't even agree with each other. So what do? What is the real answer? How many joules per mile? Well, the answer is, I have waited my whole life to give that. The most extension answer ever is it depends. Right, Kenny?
Oh, absolutely.
It depends. How many joules per mile or how many joules per acre? It depends on how much grass and weeds are on your fence, how many pieces of rusty wire you've got that connect one section to the next section, how many strands you've got, how those strands are connected. Are they in parallel? Are they just connected at one end? How many gateways you go across? How many gateways you go under with cable compared to how many gateways are you using a gate handle with a rusty hook on the end of it to jump your power across? All those things go in consideration of how many joules per mile, and there is no real answer. There's some general recommendations, and a lot of the time the 1 joule per mile is just a starting point. So what are we buying? We are paying for joules just like you're paying for horsepower on a tractor. Always buy more joules than what you think you will need. Budget for your Energizer and then try to squeeze a little more into that budget. Buy more joules than what you need. Buy a bigger Energizer than what you need today, because today there's not many weeds and grass growed up on the fence. Maybe you haven't added the 3 sections across fence that NRCS is going to pay for next year on the EQIP project. Think for the future. Don't get hung up on voltage. Voltage is important. Voltage is what we can take our fence tester out there and measure the fence with. You can't easily measure joules with a fence tester. That's more of an analyzing machine. There's only a few of them available in the U.S. and around the world for that matter. You can't measure joules easily, but you can measure voltage. And that's what we most commonly use to measure the performance of our electric fences, voltage. So most universities and animal scientists will agree 3,000 volts will control a cow or horse. 6,000 plus for sheep and goats. Sheep and goats are a little more challenging. So we want to have a benchmark. We want to measure it, but keep in mind, just because an animal physiologist tells us that 3,000 volts controls a cow, and I go out there and measure 3,000 volts with my voltmeter, does not mean the cow's going to feel the 3,000 volts, because she's not touching the fence yet, and the cow's actually shorting the fence out when she touches it because she's walking on 4 ground rods. So you want to have more than 3,000 to have an effective fence. But what you're buying joules. And if you think of it in the sense of tractors, tractors are going to have a tachometer. That's our voltage meter on an electric fence. I can take a 3000 Ford and a 4020 John Deere and park them side by side out here in this grass lot next to Jonathan's office, and I can pull the throttle back on them. So 30 horsepower and what? 80, 100 horsepower? What's a 4020? Can I say 100 and just make it up? So 30 horsepower and 100 horsepower tractor side by side out here in the yard, pull the throttle back, 1,800, 2,000 RPMs, no problem. I can take a 1 joule Energizer and a 20 joule Energizer, put them side by side, plug them in the wall, take a voltmeter, and they're both going to probably show 7,000 to 9,000 volts, just raw out of the power, out of the wall with a voltmeter on the terminals. Now I can put a 30-foot disc behind that 3,000 Ford, and I can put a 30-foot disc behind the 4020 John Deere. And I can drive around out here in the yard all day long, no problem, as long as the wheels are down and the tractor's not loaded. Little horsepower, big horsepower, I can hook a big load to both of them, but until I apply that load, I don't have an issue. Once I apply the load, once I start throwing things on the fence and adding weeds and grass, then when the wheels pick up and the disc sinks in the ground, the little 3000 Ford's going to cough and spit a little bit and put out some black smoke, and the RPMs are going to do this, and the tractor's going to die, and it's no longer going to pull the load. The bigger tractor, when I apply the load, raise the wheels up, sink the disc in the ground, RPMs may stutter a little bit, but it's going to continue to till up the sod out here and make the neighbors mad. The bigger the Energizer, the more fence you can carry. The bigger the tractor, the more horsepower, the bigger implement you can carry. So your RPMs should just be a measuring. Don't assume that if your voltage is 3,000 or 4,000, that it's always going to remain that way without any load applied to it. So that's why you want a bigger horsepower tractor, a bigger joule Energizer than what you think you need today. So power supply options. You've basically got 3 choices: 110 volt plug in the wall, battery only, which is going to require, in most cases, a deep cycle marine battery that can take multiple cycles. If you have a battery only, then you're probably going to have two batteries, one to charge in the tool shed and one to put on the fence, and then flip-flop them while the other one's charging. Deep cycle batteries are made to do that. If you have old tractor batteries sitting around that will no longer crank the tractor, then they'll run a fence charger for a while, then they'll probably eventually have the cells go dead in them. But battery only, that's an option. And then solar is also your third option. So of these three, then solar is the absolute most expensive option per joule, because what are we buying? We're buying joules. 1 joule does not cost this, even within the same brand, 1 joule does not cost the same between solar, battery, or plug in the wall. The most expensive option is going to be with solar, because you're getting three things when you buy solar. You're getting typically a solar panel made onto a big piece of plastic, a battery somehow in the back of it, and the energizer itself, which is just going to be a little part that's hidden somewhere in the plastic. So you're paying for the energizer, the solar panel, and the battery. You can go bigger and you can get external solar panels and something to hold a deep cycle battery that you'll go buy afterwards. That's also a solar option, but it's going to be the most expensive option per joule. If you have $200 for your budget, if you have $200 and you go to the farm store and you see a $200 solar and a $200 plug in the wall or mains, a $200 plug in the wall sitting side by side, and you say, okay, I worked just as hard for this $200 bill as I did this $200 bill. I'm just going to buy this solar. That's my budget, $200. The solar costs $200. I'm going to buy this solar because it'd be so much easier just to take this thing out 50 foot away from the barn where I have power I can plug it into. I just take it outside, put it right on the fence, sit on top of the T-post, plug the battery in, flip the switch, hook the leads up, and I'm good to go. I don't have to worry about running underground cable 50 foot or 100 foot from the tool shed to get out to the fence if I use a plug in the wall. I'm just going to go with the solar because it's more convenient. You have just cost yourself about 5 times more money. You're going to pay 4 to 5 times more to get the same horsepower, to get the same joules out of a solar as you would for 110 volt. Now, it costs you the same, $200 and $200, but you've got yourself 1/4 or 1/5 less power, or of the power of a plug-in. Always go with a 110 volt plug in the wall if possible, always. If it's not possible, and there's plenty of scenarios where it's not, then make sure you budget extra if you have to go with a solar system. And you can build your own. You can buy a battery energizer, and you can go buy a solar panel and source it from somewhere else, and you can go buy a voltage regulator and source it from somewhere else, and then you can go buy a deep cycle battery at the auto store and build your own, but always plan on spending 4 to 5 times more to get the same power out of solar. There have been more people than you can imagine that have completely given up on rotational grazing, electric fence, managed grazing, because they've had bad hiccups, bad experiences with electric fence because they have used solar, and that solar was not big enough to do the job it really needed to do. And that has caused people just to wad all their wire up and post and throw it in the corner of the tool shed and stick their solar energizer in the corner and just let the battery run down and go bad and say, phooey on managed grazing. Cattle won't stay in my electric fence. So it's because they...
There are some dual energizers now, right? Gallagher makes some, other companies
Oh, yeah.
do, but they're fairly large, so they could be 18 or 24 joules. Big charger, but you have to hook that up to a
fairly substantial solar panel.
Yeah, a substantial solar panel and some type of marine battery, deep cycle battery. But those are options if you're really in a place where you don't have access to electrical outlets. They're a real option, and the solar option has really come down in price in the last few years. You know, you can go on Amazon and buy a solar panel with a regulator for, I don't know, $150 now, 200 watt solar panels.
And just in most manufacturers that make a battery energizer, so what Dr. Torch is talking about, they have one at the research station in Princeton. It's a battery energizer. It has an inverter that you can plug in the back of it and plug it in the wall if you want to and make it 110 volt. Or you unplug the inverter and you plug in alligator clamps or leads and plug it to a battery and then hook a solar panel to it. And most all manufacturers are going to have recommendations on how many watts worth of solar panel and how many amp hours worth of battery you need to have to power that with. Don't go buy a 28 joule or a 30 joule fence charger and buy one trolling motor battery and a 10 watt panel this big at Harbor Freight and expect it to keep it charged up. So there's options to go big on solar only. And there's probably some photos or something online of the setup there at Princeton.
Jeremy, can you speak on joules? So if we're looking at joules and we're comparing brand A to brand B, what are we looking at?
All right, so make sure you're comparing apples to apples, because some companies will rate in stored joules, some companies will rate in output joules. Most companies will give you both. If you read deep in the fine print, you'll see stored joules and output joules. Stored joules always remain constant. Always remain constant. That is the capacity that Energizer has. That's how much horsepower it could put on the fence in a perfect world with no capacitor limitations, no resistance between the Energizer and the fence, but you'll never get the stored joules on the fence line. But it's a constant. An output joule, and some companies will list output joules and maybe even make it part of their nomenclature on their Energizer number. Output joules are the realistic amount of horsepower that gets applied to the fence under specific loads. But output joules can do this. The more load you apply, the more your output joules vary. And sometimes your output joules will step up if it's a high technology Energizer, and sometimes your output joules will peak and you keep applying load and weeds and grass and rusty connections and shorts, and your output joules go down. So output joules most of the time are going to have output joules at this specific load or this specific ohm reading. But just make sure, there's different ways companies figure it, but make sure when you compare Energizers that you compare output to output, or you compare stored to stored. Is that where you were going, Kenny? Yep, you get apples to apples. So the ground system, how does it work and why is it so important and why is this the cheapest thing to improve on? Because we all like things cheap. So an all-hot system, in this case, it's 3 strands of all-hot insulated hot wire, insulated high tensile, we'll say. You have a lead-out cable going to the red hot terminal on the fence charger. That's a cutout switch. It's just in there to show you some convenience. But you have the Energizer going to the fence, 3 strands. All 3 of those strands are joined together. They have to get hot somehow. And then from the green terminal on the Energizer, the ground terminal, there's a lead-out that goes down into these ground rods that are connected together, driven into the soil. When this cow walks up to the fence, and that fence is pulsing about every second or so, power's only staying on the wire for about 3/1000ths of a second, even though it's every second, tick, tick, tick. The power just stays on the wire for milliseconds. That's why modern technology won't get hot and start grass fires. It doesn't stay on the power on the fence long enough to heat up. So cow walks up, touches the fence. The power goes through her nose, down through her body, down through her feet, back through the soil, back through the ground, to the ground system and completes the circuit. Only when that happens does the animal receive a shock. And it happens that quick. Those electrons will find that antenna and complete the circuit. Sometimes they'll find the antenna much more effectively if the system is built properly. Now what happens if this cow jumps up in the air? Does she get shocked? No, she's not grounded. Bird can land on the wire, doesn't get shocked. It's not grounded. What happens if that cow walks up there and puts one leg on the ground and picks the other 3 up? She gets shocked a little bit, but not as much. So that's how this system works. Cow touches the fence. We're relying on the soil to conduct these electrons back to the Energizer and complete the circuit. That's an all-hot system. This is my favorite system. The alternative is a hot ground system. In this case, same style fence, except this wire is no longer insulated. It's the ground wire. This picture shows a true ground wire. Look what happens from this ground wire, this non-electrified wire. See this little blue thing? That is another wire that goes all the way back to the Energizer ground system, to the ground system that's connected to the Energizer. Every time you go under a gateway, Every time you go around a corner, every time you break that fence, if that fence is around 400 acres and it's got 37 cross fences on it and crosses 3 creeks and flood gaps and 18 gates, every time that fence stops and starts, not only do you have to get your power across, you've got to get your hot wire across to make it hot, you have to get your ground wire across, and nobody does this. Not many. I can count that many in 20 years that I've seen, that the ground wire, the not hot wire, is traced back all the way to the ground system that's hooked to the Energizer. You go out west, and they have to do this, a hot ground. They have to make that ground wire or wires hot, or have to make it connected all the way back to the original Energizer ground system because of their mineral content in their soil and the lack of moisture. For some reason in the southeastern U.S., we have a lot of fences that are 4 strands or 6 strands or 5 strands of high tensile, and only 1 or 2 of them are hot, and the other 2 or 3 are just there. They're just stapled right to the post. Well, what's that for? Oh, it's my ground wire. I got a ground wire I drove out there on the back of the farm, connected to it, and over here, and well, is it connected all the way back to the Energizer ground system? Well, no, it's just a ground wire. Don't know why they do this. If you have a 4-strand fence, and 2 of them are hot, and 2 of them are just neutral, holding the earth together, wasting wire and your money, then you're leaving 50% of your power carrying capacity on the table. Unless you take those other 2 wires or other wires and connect them back to the ground system, now you've got a hot fence. So in a proper built system, the way this would work, cow walks up, touches the hot wire only, power goes through, body down, legs, back to the soil, back to the ground rods, shock. Cow walks up, touches the hot wire and a true ground wire, because this is connected back to this, which is directly connected to that. It's almost an instant shock. You lose a little bit because of resistance over distance. But it's almost the same of walking up to the Energizer and a cow putting her nose on the hot and her tongue on the ground at the same time, and her body completes the circuit. That's the only way a hot ground system works effectively. It's just like taking also, and this is why I don't like these systems, where I live in Muhlenberg County, where I have fence that goes through the woods. If a tree limb falls on this fence overnight and mashes those 2 wires together, my true ground, very effective, shock the fire out of a sheep that are hard to control to begin with. If a tree falls on it, mashes those 2 together, what's happened to my fence? Short, just like taking a screwdriver and going up here and going hot to ground. Short the fence out, Energizer quit splashing, everything's probably not going to work out too well. On this system, if I have a tree fall on my fence, and my luck, it probably did fall sometime this week while I've been gone, tree falls on the fence, mashes all 3 of those hot wires together on a section of earth this long, nothing is going to happen. Maybe a hiccup. Maybe lose 500 volts or maybe lose 1,000 volts because it's just relying on the current of the ground back to the ground system to short it out. I can have 2 top wires mashed together by a little tree limb. No big deal. I got 2 hot wires mashed together. I got a tree limb laying on it. Tree limb is several thousand ohms of resistance. It's not very conductive. It's not going to make a bit of difference as long as it's not laying on the ground where cows can step over it. But it's psychological barriers, so they're scared to death of it anyway because they know there was a fence there. Even though it's laying on the ground, they're not going to cross it. So a hot system is what I prefer. Hot ground system is great for hard to control animals like goats and sheep or cattle out west, but if you get 2 wires together, you got a problem. Plus, if I've got multiple strands of wire, I want them all hot. I want to carry as much current as I can for the longest distance I can, and we'll get to that in a second. So what is the grounding rule and why is it so important? What makes this right here the key to shocking the animal, and what makes it the cheapest thing? So the general recommendation minimum, remember we can go above the minimum, 3 ground rods, 6 foot deep, 10 foot apart. That's the minimum. The only exception, and this is a whole different conversation, whole different situation, would be for grazing. And if you're packing a solar fence charger and a roll of poly wire and you're moving it across the farm every time on a quarter mile or so, you can get by with a couple of portable T-handle ground rods that are easy to get in and out. That's the only exception. We don't even like to talk about that at the regular fencing school. But If you have a permanent energizer, whether it's a solar that's going to sit in this one spot all the time, or if it's a plug-in that's going to be plugged in the barn all the time, the minimum 3 ground rods, 6 foot deep, 10 foot apart. That's the minimum. You may have to have more than this. A lot of cases, you should have to have more than that because you should have an energizer that's bigger than what you need. Bigger energizers need more ground rods. It needs a bigger antenna. Bigger farms need a bigger antenna to pick up the signal all the way across the farm. So, with that in mind, keep your ground system 30 or 40 feet away from your utility ground. Don't share the same ground rod as you do on your tool shed or your house. Don't hook your energizer to your house ground system. The ground system on this building is for safety purposes. You drive around Russell County or go down to Clinton County, look at some of these old farmsteads that have power run to them. Old farmhouse, still got power hooked to it. That ground wire hadn't been hooked up in 50 years. Somebody knocked it off with a snapper riding mower deck in the 70s, and the lights still come on in that old tool shed. Right? We don't have to have the ground wire hooked to the ground rod to make the lights come on in this building. It's for safety purposes. This ground system here is not for safety, it's to shock the fire out of something. We don't want that ground system gets hot. When an animal touches it, it gets hot. I'm seeing electrons through the soil making those ground rods hot. I don't want the ground rod to my house or the extension office or my tool shed getting hot every time a cow touches it because she's shorting the fence out and putting so keep them separate. We don't want interference with our electronics in our house. We don't want interference on our fence. We don't want stray voltage to come through our house and go to the fence and tear up a $1,000 fence charger. Keep them separate. It's real easy to do. And what are most of your house and tool shed ground rods going to be made of? Somebody say copper. Copper! We don't ever want to use copper with electric fencing. In very, very limited, rare cases. We definitely don't want to use copper ground rods for our ground system on our electric fence. And the reason why, you never mix metals. Never mix copper with it. Copper is a wonderful conductor. It is so wonderful that it absolutely despises any other type of metal that you touch to it. It'll corrode. Copper and galvanized join together, run some electricity through it, expose it to some ambient conditions, it will corrode. The copper will eat the galvanization off of the metal and then start eating the metal away because of electrolysis. It is not avoidable. Now you can put some special salves and juices and powders on it that the electricity uses to join different metals together, but just keep it simple and use a galvanized ground rod, galvanized wire, and hook that to your galvanized energizer terminal. 3 different connections, all the same type of metal. You're not going to have an issue. I've seen hundreds and hundreds and hundreds of energizers on the repair shelf at farm stores, and the ground terminal is completely burning too, and sometimes even the hot terminal. Not from lightning, not from a fire, but just a big black spot and looked like you took a sawzall and sawed a hole right in that split terminal. That's because somebody chucked a copper ground rod in that galvanized terminal, and over time, because the ground rod gets hot, it gets hot when electricity flows through it, over time it just eats the ground terminal off of it. Don't join copper and galvanized. You say, what about stainless steel? Stainless steel is okay. Stainless steel is not a good conductor. That's why on your large energizers across the industry, you will see galvanized terminals on the energizer. Stainless steel will be on your smaller energizers. Galvanized will be on your larger ones. Don't join copper and galvanized. It will corrode. Keep your ground system. If you've got galvanized water pipe or galvanized water troughs, keep your ground system as far away from that as possible. Stay in that 30 to 40 foot rule as well. And you may have to add more ground rods. There's ways to test it. If you want to actually do this and get deeper, then come to the Electric Fence Troubleshooting School. We'll go through all that. There's some good pubs. There's one probably in your handout. Virginia Tech has a good publication. The grounding publication you have from UK in your folder, it'll give you an overview of how to test the ground system. Easy to do. Short your fence out on purpose. Measure the voltage at your ground rod. If your voltage is higher than what it should be, add more ground rods. The typical recommendation for grounding is about 3 foot of ground rod per joule. About 3 foot per joule, but 3 ground rods should be the minimum, 6 foot deep. I know some of you are looking at me glossy-eyed saying, I can't get a ground rod more than 2 foot deep at my farm. Well, my neighbor can't either. And he's only got one rock, but it's a great big rock. And it stops about halfway across my farm. So I've got the same problem. I have 10 ground rods now, because I've got a 58 joule energizer. It took 10 ground rods to get my voltage down where it needed to be when I shorted the fence out. So 10 ground rods, the first 3 or 4, I drove them straight in the ground, no problem, 6 foot deep, right along a fence line. The next 2 or 3 started hitting rock. So for a little bit, it's sand rock. I stood up on the back of a side-by-side with a $30 hammer drill that I wasn't too worried about if I tore it up, and I drove my half-inch ground rods in using that hammer drill, and it worked okay. Put a little water in there, and you can soak them in. And then the last 2 or 3 I've got, I had to either drive at an angle or dig a trench and lay them down flat. Now, my neighbor, he had to lay all of his down flat. As a matter of fact, he laid some down flat as deep as he could dig. And he took a big piece of galvanized industrial sheeting. It looked like it was probably an 1/8 inch thick or 3/16 thick galvanized corrugated metal. Buried it, drilled holes in it, and he's got his ground wire connected to it. So he's got a pretty good ground field. If you can't go 6 foot deep, then at least try to cover 6 foot of soil. You may have to add more. You can leave some sticking out if you want to. It's not a problem at all to leave some sticking out. Bury it. Yep. Yep. You may have to check it a little more often to make sure your galvanization doesn't wear off where it's been contacting the soil for a few years, but you'll check it every so often or check the current on it by testing it. So, ground systems, galvanized ground rods are cheap, $10, $15 a piece. It's pretty slim chance somebody's going to dig up your galvanized ground rod and sell it for scrap metal. I'm not saying that would happen in Russell County, but there's parts of Muhlenberg that people had their copper ground rods stolen. So ground system, that is the weakest link in a lot of cases. Also, don't let your lead out wire be your weak link. Don't use little bitty skinny lead out wire to go a 1/4 mile across the farm on an offset to get to your 4-strand high tensile fence. If it's smaller than your high tensile, yes. Okay. Always make sure your lead out. The wire coming from your energizer to your fence is at least the same size as your fence wire. The more distance you add up, the more resistance you get. So if you are starting out with a offset fence like you'll see today, and you're going to go several thousand feet with a single strand of bare exposed hot wire offsets, and then you're going to go halfway across the farm and dump that power into a 3 or 4 strand cross fence, then you may have to run 2 wires in that offset, because that one wire, it's like starting out with a 3/4 inch water line. You'd never want to start out with a 3/4 inch water line and go all the way across the farm and then dump it into a 2-inch water line. You always want to start out bigger and then size down. So it's easy to do with lead out. If you're not careful, you can have too small lead out cable. Resistance. So why do I like a 4-strand or a 6-strand fence with all of them hot? And simple electrical math and electrical theory is the reason. If we look at resistance, 12.5 gauge high tensile wire, 56 ohms per mile. We'll just use that as a standard. That's going to be the most common thing we're going to use for electric fence. If you could use aluminum, it would be wonderful, because aluminum is 18.5 ohms per mile. If it was 12.5 gauge, it's not suitable for permanent fence because aluminum just keeps stretching and stretching and stretching and stretching. High tensile wire, 1% stretch. That's it. It's always going to try to go back to its original length. So aluminum, not a good option for permanent fencing, but it's a very good conductor. If we look at stainless steel poly wire, for example, 6-strand stainless steel poly wire, not a good conductor. 1,000 ohms per mile. A lot of resistance. A lot of things that are trying to stop that electricity from flowing. So if we take 1 strand, a 12.5 gauge high tensile at 56 ohms per mile, that's our benchmark, and go across the farm. Then we add another strand below it, so I'm going to go a mile. I'm going to pick one of these big, long, straight farms in Russell County that's flat that you can just see for miles. And I'm going to go a mile across this bottom with 1 strand of high tensile. It's got 56 ohms on it on that mile. And then I'm going to drop down here and I'm going to put another strand. 2nd strand. I'm going to go a mile across that bottom. And I'm going to jump them together because you got to get the second one hot somehow. And now I'm going to stand back and look at it. It goes all the way across the bottom a mile, all the way across the bottom a mile, and I got them jumped together here, and that's it. So when I plug my Energizer up to that, the Energizer looks at those 2 strands of fence that run a mile, and it says, okay, I've got 1 mile of fence, I've got 2 miles of fence. And they're both 56 ohms per mile. Now I can trick my Energizer into thinking that is more or less than 2 miles of fence by simply going to the other end and connecting those 2 wires together again in parallel. Now the Energizer looks at it, and all it sees is 1 mile of fence. And I can take 2 more strands. So if I've got a 2-wire hot fence with 2 wires that are neutral, not a real ground, just 2 neutral wires holding the earth together, I can take those 2 hot wires, I can insulate my other 2 neutrals, I can join them all 4 together, up and down at this end, go across this stretch of fence, jump them up and down at that end. My resistance has now went from 56 ohms per mile, 2 strands, if I join them together in parallel, both ends, 28 ohms per mile. That 4-strand fence that I went back and added insulators to because the contractor left me with 2 neutrals, 14 ohms per mile. I want 0 ohms per mile of resistance. I want no resistance. I want nothing stopping that electricity from going down the fence line and shocking the goat when it touches the fence. I'm getting closer to 0 at 14. It has to be connected in parallel. The Energizer now looks at that as 1 mile of fence, and it's not just 1 mile of fence this big around, it's 1 mile of fence this big around that has more surface area to carry the power. I can go further and carry more power with multiple strands than I can with 1 strand. A 6-strand all hot fence is much more effective and easier to electrify than a 1-strand high tensile fence over this. That's it, right there. 8 cents worth of wire. And I've quadrupled. I went from 56 ohms per mile. If I didn't have this, 56 ohms per mile. 1 mile, 2 mile, 3 mile, 4 miles. 8 cents a wire, 14 ohms per mile, just like that. Easier to electrify if it's hooked in parallel. Don't use the small wire. The bigger the wire carries more power, just like water pipe. If you got a big enough pump, big water pipe, you can carry more power. If you got a big enough Energizer, the larger diameter wire carries more power. Don't use the little 17 gauge stuff off the bottom shelf at the farm store, the soft wire. 1, it'll rust next year because it's class 1 galvanized, and 2, it doesn't carry much power because it's small diameter. That's why we talk about 56 ohms per mile, 12.5 gauge high tensile being the standard for permanent fence. So you'll see more options on how to incorporate hot wires with our existing physical barriers, and this is something that if you're doing this on NRCS cost share in Kentucky, you may have to make some modifications to and bend a little bit with them. In all the surrounding states, NRCS has changed their specs to make it a little more user-friendly and actually make it make sense. So we see a lot of times somebody will build a woven wire fence and you put 2 strands of barbed wire at the top. Why do they do that? Any idea? I'm being serious. Somebody tell me why at 50 inches tall I go up another 4 or 5 and I put 2 more strands of barbed wire at the top. Nick? Horses. Because horses will not scratch on barbed wire. And everybody wants barbed wire with their horses. Maybe they're trying to catch deer. I don't know. Great way to catch deer. Build you a woven wire fence. Good stout fixed knot fence like Peyton's going to show you. Put your 2 strands of barbed wire at the top. Run it out through a pasture that's got a heavy deer density. And just wait, because you will have deer tangled up in that at some point or another. And those deer are still going to be there when you find them 6 days later. Not a good idea. Not good for wildlife movement. So I don't know why NRCS in Kentucky still requires 2 strands of barbed wire at the top, but they do. What could we do to make that a little bit better maybe? Well, put the barbed wire at the top. Sheep will still rub on it. Let's put a hot wire at the top of it. Put a hot wire at the top. Something goes wrong with the strainer. Now the hot wires land on the woven wire. Fence is shorted out. This is a great idea, a hot wire at the top, if you have horses or giraffes. Those 2 things. Horses and giraffes will reach over the top of the fence at 50, 54 inches tall, which is where that hot wire would be when you replace the barbed wire. If you have cattle or sheep or goats or other things, where are they going to scratch the fence at? Where are they going to pressure the fence? Right here at rump level. They're going to rub right there at rump level. Now, you can't starve an animal in. So there's probably a reason why those animals are reaching under the woven wire. They're even reaching through this barbed wire that he put at the bottom because everybody knows barbed wire stops animals. But animals are going to pressure the fence starting at about nose level when they're resting. So why don't we put the offset hot wire at rump level on an electric fence? In Virginia, you can do that. In Virginia, NRCS says you don't have to put the barbed wire at the top, you put a hot wire down at nose level. Tennessee's the same way. Kentucky will probably be the same way eventually. Put it where it's easy and convenient to use. If I have a hot wire at about 32-ish inches, then look what I can do now. I can hook onto it with a reel and I can do some managed grazing. Because all of this is a capital investment to my land. It's all good and wonderful. It secures my animals. But when I can start doing this, I can start seeing returns. It makes rotational grazing easier. The offset does if it's down where the animals are rubbing the fence. So they're not going to pressure the fence anymore with their backside. You can also get into trouble if you're not careful with older fences that flop around. There's a good pub on that. Not going to get deep into it, but you'll see some offsets like this in the field. There's a pub in your handouts on offsets and how to use them and where to apply them. Flexibility, you're going to see some very flexible systems built out in the field today. Peyton's fence is going to be a lot more flexible than what the old hinge joint fences were from 30 years ago that had a post every 10 foot apart. The one Nick's going to build is going to be extremely flexible. Great for people that think they've got the highest deer density in the state, because everybody in Kentucky thinks their county has more deer than every other county, and that's why they can't use electric fence. I can't use electric fence, got too many deer. The deer just tear it down. He's going to show you a very flexible fence. T-posts are not flexible. They are the least desirable to use in any fence system. Just stay away from it. I don't even want to show my fence a T-post. The T-post I have at home that are from an old barbed wire fence on the back side, I've got them piled up behind the old tobacco barn in a thicket. I don't want my fence to even look at it. I don't want to show it a T-post, because T-posts are an accident waiting to happen, and it will happen eventually, especially if you use the cheapest insulator you can find to put on the T-post. When that little thing breaks, the wire pops out, hits a T-post, dead short. So stay away from T-posts. There's options on flexibility. We'll talk about those. Post spacing on high tensile electric. The further apart you can spread your posts, the more flexible your fence is. And you can go with some wide post spacings depending on the solution you're looking for and the type of fence you're building. 30 to 50 foot in Kentucky, that's where your range is probably going to be in most cases with ground doing this. Now you get on some ground that's maybe not flat, but it's all in the same plane for 1,000 foot, then you can spread your post out a little more. But every time you do this, you've got to take in consideration putting your posts a little closer together or driving maybe some wooden posts. You'll see that today. Brace assemblies, you'll get all you want of that in the field. One thing you won't get is an example of a brace built in curves, because we don't build braces in curves. Do we, Peyton? We don't build braces in curves because braces do no good in curves. We don't show people how to waste their money at the UK Fence School. If you want to waste money, build you some braces in a curve. Because the only way that brace works is, and this is right out of the Stay Tough book, right here, good diagram. The only way this brace works is directly in line, 180 degrees from this post to that post, just like that. If you pull off the side of it, it's in a curve now. If I build another one and pull off the side, it's in a curve. They don't work in curves. They don't serve any purpose in curves, and they only work if you tie the wire off and strain from it. If you just run the wire, there was a conversation earlier about building braces every 330 feet and just run the wire by it, maybe tack it off with a staple. Don't do that. We'll show you some ways to tighten up your brace wires to where it's not going to interfere with animals and with electric fence if you're going to use that. Flowing through curves. 20 degrees, you can bend 20 degrees off of a post. We're not going to have an example in the field today. We did a couple days ago at the other fence school, but you can flow through curves as long as you're not turning more than 20 degrees off of an individual post. NRCS now across the U.S. will allow you to turn a curve without stopping and starting the fence and building 90 degree, 120 degree braces. And the way you do that is you don't pull more than 20 degrees off of a post. I think there's one state, Virginia may require a 15 degree or less turn, but in Kentucky, you're at 20 degrees. The way you do that is if you're turning a curve, I'm going to turn around there to where the coffee machine is, and I'm starting out here, And so I got my last wooden post behind me, and I'm going to keep on going straight. I'm going to go straight 8 feet, right in line with that post. I need to be over there, but I can't get there yet. So I'm going to go 8 feet. I'm going to step over 35 inches. I'm going to step over 3 feet. Now I'm 20 degrees off of that post. Real simple cowboy math. And now, if I need to turn again, I'm going to line up this post and the post behind me. I'm going to take 8 more feet. I'm going to step over 3, or 35 inches. Now I'm 20 degrees off of that post. I can fence in circles and never build a brace until I get to the beginning and the end of that fence and save money. Braces, over $100 now. Over $100 for a brace assembly. That's just for one direction. If you're stopping and starting a fence correctly, you got to have a brace going this way and a brace going that way. That's probably $175. So we can do this. It's easy to do. Water gaps. Don't let this be a weak link in your fence system. One way to do it is with chains. I used to design a lot of systems with chains until I kept having constant complaints of chains getting tangled. And so you try to use welded chains. Well, welded chains hang a lot better. They don't get as tangled, but they still get brush in them. Or something goes through it, a log or something, when the water gets up and it flips the chain over. So what I started doing is designing these floodgates with pipe hanging down. Use a little short piece of chain or a short piece of high tensile. Take a piece of 1/2-inch pipe, whatever the cheapest galvanized or aluminum pipe you can find is. You hang that down from a short piece of high tensile or a short piece of chain and mash the end flat with a hammer or a vise where you can drill a hole through it. Those pipes will flex and move, but they won't get tangled around each other. So the pipes work like any of this is better than tying a bunch of pallets and panels and old gates to the bottom strand so the flood can just make a big mess of it. This I can do it. Everything's electrified. Lighting protection, surge protectors, ground systems, that's the way to protect your investment on your lightning. Okay. Modern technology can do a lot of things. Modern technology is made to be low impedance. Weeds and grass do not impede the performance of the fence very much. Power only stays on the wire for a short duration of time, so it doesn't heat up and cause shorts and fires. Modern technology cannot perform miracles. There's a good discussion about maintaining your fence line right before the break. You can't let it get like this and expect the power to still flow through it. You can't throw enough joules at it to make this work. I've got 5 times as many joules as what I need at home. I hardly ever spray more than once a year on my fence line, but I do have to do some kind of maintenance because it'll eventually look like that. You can't. There's a fence in there. Right here's a post right there. But it's not a very effective fence. We'll talk about some of these things. Does everybody know what this is? This is a 10-cent insulator, or maybe nickel. What's that? It might as well be. It might as well be garden hose. If somebody were to give you a bucket of 4-inch fin tube insulators, then they are not your friend. The reason they're giving you that bucket is because they used them on their fence and the whole thing's shorted out and they don't even want it on their farm anymore. Don't use the 4-inch fin tube insulators if you want a fence that's going to be effective. If you drive this thing in, what is this thing here, this little U-shaped nail? What is that? What? A staple, okay. Some people call it a steeple. Anybody call it a steeple? Okay, see? Could be a steeple. I grew up calling it a steeple. I catch grief for it every time I mention the word steeple. But if you drive this device in too tight, then it cracks the insulation in this little 10-cent, not worth a dime at all, piece of plastic, and it leaks. If you don't drive your staple in tight enough, then the fence flexes all the time. The fence does this all the time. High tensile wire is going to stand and wave in it. It moves, moves, moves. It'll eventually slide out of the way. Now you've got wire against a post. One post, not a big deal. You get 300 of those across the farm and the posts get wet over time, you've got a short that you cannot track down with a fault finder. Nick's got some fault finding equipment that'll take you almost directly to a short, but if you've got 300 of them, you're not going to be able to find which one the problem is. Same way with those things that wrap around the backside of a post. I don't really recommend those. go buy the cheapest insulator you want to, and this is a good way to get exercise because you can go back every year with a 5-gallon bucket full of more cheap insulators and replace them. Little ear breaks off, wire falls out, hits the T-post, dead short. Luckily for this fence, this is barbed wire. And the barbed wire wasn't the insulator. So what is that a good implication of? The barbed wire was electrified. Don't electrify barbed wire. Please don't electrify barbed wire. Your neighbors, don't be laughing because your neighbors do that. Well, don't electrify barbed wire. There's a lot of things that can go wrong here. Barbed wire is not made to be electrified. You get a lot of resistance built of it. You get fields of electricity that interact with each other. Most of all, it's a safety issue. If you've got 2 or 3 strands of barbed wire, maybe one of them's hot, maybe they're all hot, something gets tangled up in that. The first shock is going to thrash around a minute. If I get shocked by a multi-strand high-tensile fence and I flop around for a second to get away from it, I can get away from it because it's smooth, and the pulse lets me get away. If something gets tangled up in a strand of barbed wire that's pulsing, it's not going to be a good day for that animal or person. Because if they thrash around and get tangled and tangled, the electric fence is not going to be detrimental to them. The shock, they can take the shock. It's the not being able to catch their breath between the shocks. Don't electrify barbed wire. And we'll talk about some other things. If it can be done wrong, this is the example. Broken yellow insulator, zip ties, PVC pipe, and water hose. If you want to have a failure, and if you're looking for a reason to quit doing any type of electric fencing or rotational grazing or making money because you're managing your forage system, then cobble together a bunch of stuff like this and just sit there and wait for it to fail because it will. So build your fence right the first time. Don't take the shortcuts you don't have to. There's some shortcuts you can take. Don't take the silly ones. If it doesn't make sense, it's probably not a good idea. This is an investment. This is a capital investment on your farm, permanent fence is. Treat it like it. Remember, your fence, whether it's the one Nick's going to build or the one Peyton's going to build, that is going to work around the clock. It's working when you're not. So don't cut any corners with it.
Any questions for Jeremy while I switch over?
Yes.
You had mentioned electric fencing troubleshooting school or something like that?
Yes.
What is that?
So electric fence troubleshooting school, typically we do that the first or second week of June. Keep an eye out with your local county office, your extension office, then there will be some advertisements. Dr. Toich will have advertisements that go out all over the state in several different manners, and then also at the local offices we'll advertise